Welcome to the Chapter 2 review. Remember to complete the required chapter reading material for a more thorough understanding on all the material that's covered. You are responsible for reading through the chapter in its entirety. Chapter 2 includes a lot of information to know, but you can begin by familiarizing yourself with the different statistical terms. This is going to be helpful as you continue to read, not only through the textbook, but also when you take a look at different scholarly journals. You'll come across some of these terms, so it's important to know exactly what they mean and the context in which they're used. For example, being able to identify the variables in data from a study, understanding what it means when research refers to a sample population, knowing the differences between discrete data, continuous data, ungrouped as well as group data. The textbook does go through these, and they list more objectives as well, so be sure you read through and familiarize yourself with all of those. As the textbook discusses, there are 4 scales of measurement that you want to be aware of. Why do we need to know these? What are the importance of these? Anytime you have data or variables, you'll need to know how to group those variables and how they apply to you in any given situation to make sense of whatever the scale is, whatever the assessment outcome is. Each scale of measurement requires a different statistical analysis. So when you're looking at data, you'll know what procedures were followed or what need to be followed. The nominal scale of measurement is the most basic. As you can see here, it's simple, it's specific, it's clearly identified, and each category by itself is just as important as the others. There's no ranking of these categories. The ordinal scale gives you a little bit more information. You're able to rank scores from lowest to highest, although you really don't know what these scores mean at this point. For example, if you time students in the shuttle run to test for speed and agility, you can list who was first, who was second, and third, but you don't know how much faster first place is than second place, and second place is the third place. And I'm not sure if you're aware of what a Likert scale is. That's listed there, but these are the categories typically found on surveys, and those range from things like you strongly disagree about a subject, you disagree, you neither agree or disagree, you agree or you strongly agree. And so that's what a Likert scale is. It's when you have a category, a survey that has those different groups of categories there. Then you'll see the interval scale, which provides a little bit more information, including a distinct difference in units of measurement between variables within the scale. For example, with an interval scale, we know exactly how much difference there is between scores. If a student performed the mile run, we know that an 8-minute mile is exactly 60 seconds faster, and always will be 60 seconds faster than a 9-minute mile. The time differences are standard, and those will not change within the interval scale. The ratio scale includes the qualities or characteristics of all those listed within these scales. And while most physical educators will use a variety of scales, the majority of scores and data will fall into the ratio category that you're typically working with. So just be familiar with the different scales of measurement and the importance of each of those. Now, when we think about a normal distribution, we want to know what that is and why we come to this in our understanding of statistical analysis. A normal distribution represents the distribution or the spread of several different variables, scores, or results from a test. Now, data, when it's represented by a graph, can be distributed in a lot of different ways, but there are many cases in which the data seems to be grouped predominantly around a central value. And this is visually demonstrated by what we call the bell-shaped curve. When we plot information on a chart, we can list the scores and how often each score appears in a given population. And I'll show you more on this in just a second. But this helps us to see a graphic representation of our data, which we can then use for additional statistical purposes, for evaluation, and for analysis. So let's say, for example, we're looking at GRE, SAT, and ACT scores. These typically follow a normal distribution. It's revealed that the majority of students will score in the average range, which would be considered a grade of about a C. The mean or average is represented by that little X with a bar above it. Just familiarize yourself with that. And then a smaller number of students are likely to score in the B or D range. And an even smaller number will score in the A or F range. This creates a distribution that resembles a bell, where we get the statement bell-shaped curve. Let's say that we administered a test to students that had a total possible score of 100 points. When we put these scores into a chart or a graph with the scores at the bottom, which is on the x-axis, and then the amount of times each score was received on the left side of the scale, which is the y-axis, we place an X on the chart for each score, for example. In this case, One student received a score of 81. One student received a score of 82. One student received a score of 93. One a score of 95, and one a score of 96. 3 students received scores of 84, 85, 86, 91, 92. 5 students all received scores of 87, 89, and 90. And then 9 students received a score of 88 on this particular test. Now, this is a fairly similar layout as the bell-shaped curve, demonstrating what we consider a normal distribution or close to a normal distribution of scores. But not all distributions are normal. When scores on a test create different distributions, different layouts, different spreads, we can create different visual layouts or graphs to help us understand exactly what's happening. So some of those different layouts include what we call the leptokurtic curve. And this represents a higher percentage of scores around the mean. So there's this peak in which a lot of students scored right at that average area, and then it kind of narrowly drifts off on either side. There's also what we call the platykurtic curve, which indicates that scores are a little bit more spread out. There's not this huge cluster or peak around the mean area. There's a mean, but they're a little bit more plateaued, a little bit more spread out. There's also the bimodal curve. There could be curves in which there are 2 means. So we have these groups of students that scored similar results in 2 different areas. So the means form this double curve. So the bimodal curve, we have a layout like that. And then we have the skewed negative. Scores could be clustered around the high end of the scale where students are scoring high, which that's where the mean is, with fewer students scoring low, creating this skewed negative curve. And so we see this peak at the high end. And then the majority of scores could also be at the low end, giving us a low mean score with fewer scores at the high range. And this gives us a skewed positive scale. So there are several different layouts that represent different distributions. Now, understanding what these distributions are is helpful to understand more about the results. We'll need to investigate a little bit more to determine if the test maybe was poorly developed. Remember, we want to focus on tests that have validity and reliability. We can also determine if we as a teacher did a good job or poor job at providing instruction. Regardless, we need to look at these curves and try to make sense of them, but we can only do that through some form of statistical analysis within measurement evaluation. Now, the standard deviation is another statistical calculation that identifies how the scores are spread around the mean. It helps us to identify the reliability of a test, and a low standard deviation means that a test is more reliable. This is when the scores are mostly close to the mean, so we have this cluster around the mean area. The further away or more scattered the spread or the scores are around the mean identifies a low reliability. And there's a complicated and sometimes confusing calculation to obtain the standard deviation, and this is reviewed in the textbook. I don't want you to worry about memorizing that calculation or memorizing that formula. It is helpful to know how you get to the standard deviation, but there are programs and calculators that actually do the work for you, so I don't expect you to memorize what that formula is, but just familiarize yourself with it. Another thing that the standard deviation does is to help us distinguish reliability based on the average score of a test. For example, if we have 2 tests and the average on both tests is the same, does this mean that we have reliability or the same amount of reliability? If we calculate standard deviation, we may see that there is a difference in reliability of these 2 tests, although the average, the mean, is the same. The scores for one test may be more scattered when we graph them, and the other tests are more clustered together around the mean. So simply knowing the average doesn't really tell us what we need to know about a test, but doing some additional statistical analysis is going to give us more information as to the reliability of that test. Now, some professors will probably say that the standard deviation really doesn't do much, and that might be true for the basic physical educator. But if you want to really investigate whether or not you're providing the best quality instruction and you're looking at some of the test results that you're getting, I mean, it can provide some helpful tools or some helpful outcomes. So there are some benefits in knowing what the standard deviation is. The measures of central tendency are those most basic statistics that are used in understanding scores and outcomes. Just as we didn't go into calculating the standard deviation, I don't want to spend a lot of time and go into explaining how to calculate these because it is very simple, and there are programs that will give you all of this information, whether you're using Excel or maybe even a calculator. It's a good idea to know how to calculate these though, so take a moment and familiarize yourself with how to do that. And once you have a good understanding on how to obtain the measures of central tendency and what they mean, you can then move on to measures of variability, to range, quartile deviations, percentiles, ranks, and even frequency distributions. Although most physical educators don't get this far into statistics of test scores and data, this is what forms the foundation of scholarly research. And so you do need to know what you're talking about when it comes to conveying information and making some sense of the test and the scores and the instruction that you're providing. To understand what you're talking about, you need to understand the role that statistics are playing in your results and in your test and in your development of those tests. So take some time, read through the remaining content of the textbook in Chapter 2. This is going to be helpful in improving your understanding when it comes to the purposes of collecting, analyzing, interpreting test scores, or even test results. If you have any questions, please don't hesitate to contact me. That's all I'll give you for now.